Hello and welcome students. Today we are starting with a new topic, application of derivative. Now this topic, application of derivative, in short it is also written as AOD. So if somebody says AOD in calculus, you should understand that they are talking about application of derivative. Now in this topic of application of derivative, what are we going to study? See, as such, application of derivative is a very vast topic. But our 12 standard syllabus is restricted to few of those topics. So the first part that we are going to have in application of derivative is application of derivative to geometry. Now see, as the name suggests, in this topic, what are you going to study? You are going to study the application of derivative. Whatever you have studied in derivative, now you are going to apply it. So application of derivative. Now where can you apply derivative? So the first thing that we have here is application of derivative to geometry. So we will study application of derivative to geometry. We will apply the concept of application to geometry. And in this, what are we going to study is, we will study tangents and normals. Application of derivative to geometry we will apply, and then we will study tangents and normals. Tangents and normals. Tangents and normals to a curve. That I will teach you later in detail. Right now, I'm just writing what we are going to study. So this is the first application we have. That is application of derivative to geometry. Then after this, we have application of derivative as a rate measure. We are going to apply derivative as a rate measure. That is the measure of rate. The measure of rate. Measure of rate. So what I'm saying application of derivative as a rate measure. Application of derivative as rate measure. Some students write rate measurer. They write rate measurer. It is one the same thing, rate measure or rate measure. You have to understand that you are going to apply derivative. You are going to apply the concept of derivative to. You are going to apply the concept of derivative to calculate the rate. To calculate the rate of change of something. Okay. This is application of derivative as rate measure. And in this, we are going to apply, see this concept, as we apply the concept of application of derivative to geometry, to tangents and normal to a curve, application of derivative as rate measure we can apply at various places wherever there is a change in the rate. Okay, problem based on change in rate. So here we will have problems based on rates and changes in rates. Then next we have application of derivative. We have application of derivative to Physics. Application of derivative to physics. It would be more appropriate if I write application of derivative to motion of a body. Application of derivative to motion of a body. In this, what we are going to learn? We are going to learn, that is, we are going to apply this concept on velocity. You know what is velocity? Rate of change of displacement. Acceleration. You know what is acceleration? It is the rate of change of velocity. And jerk. What is jerk? Jerk is the rate of change of acceleration. So this covers one part of application of derivative. One part of application of derivative. Then we have application of derivative we will apply application of derivative to calculate some quantities approximately. So we can write application of derivative for calculation, and that topic we will call it as approximation. What are we going to do? We will use the concept of derivative to calculate the value of certain functions approximately. So that topic is known as approximation. So you can write here, the topic name is approximation, and you can write here application of derivative for approximate calculations. For approximate calculations. Then next we have two very important theorems which are known as the mean value theorems. They are known as the mean value theorems. In mean value theorems, we are going to study Rolle's theorem. So we will study Rolle's theorem. And second, we will study Lagrange's mean value theorem. This all comes in application of derivative. Lagrange's mean value theorem is also known as LMVT. Then we will have the concept of increasing function and decreasing function. Increasing and decreasing functions. This also we will study with the help of derivative. Increasing function and decreasing function. And in this section, finally we have maxima and minima. Maxima and minima. So this is our syllabus. This is our syllabus so far as application of derivative is concerned. So you have this part. What are the parts that you have? You have 3 parts here and 4 parts here to be done. So we will start with the first topic in various topics under application of derivative to application of derivative. And the first topic is application of derivative to geometry. So let's begin. See here, I have drawn a function here. This is the plot of a function, and I will name that function as y equal to f of x. As you know, if you have a function, it can be plotted on xy plane. So I plotted this function y equal to f of x. Now what I do is I draw a tangent to this function at a point. You understand the meaning of tangent to a curve. The function is a curve. The function y equals to f of x is a curve. So we can use function and curve for one another. So here we have y equal to f of x is a function of x, and then I have a tangent to the curve. At what point is the tangent? Say the tangent to the curve is at point x equals to a. Okay, so let me first draw the x and y axis. So here we have y axis, and I have x axis here. This is x axis, y axis and x axis. Now this point where I draw the tangent to the curve, the point is x equals to a. What is the x coordinate of the point? It is a. Now students, you all understand the property of a tangent. When I say tangent to the curve y equal to f of x, and let me name this tangent as t. If I say like this, what does it mean? It means a tangent which is a straight line and the curve, they have one and only one point common in them. The line is touching the curve. Now when I say line is touching the curve, there is one and only one point common between the tangent and the curve. That is, there is one and only one point common. Okay, see, the line is touching. I give you one more example. Suppose here I have a line, and look at this line. Look at this line. Now this line is not touching the curve. It is intersecting the curve at 2 points. One point being this, and the other point is this. So here what you have, this blue line which I drew, that is not a tangent because it is cutting the curve. What is a tangent? Tangent is a point which is touching the curve. And remember, when a tangent is a line, I'm sorry, I said point. Tangent is a line which is touching the curve. And when I say touching the curve, remember, there is one and only one point common in both. So if I say, let the point be capital A, let the point be capital A, where the tangent is drawn to the curve. Okay, what I said earlier, I said the point where the tangent is drawn, that point has x coordinate a. Okay, so if I project that point on x axis, I will get here small a. Okay, small a is a number. Now remember students, so if this number here is a, so what will happen? Point A which you have on the curve and on the line, remember point A is common to both. It is common to both. It is on the line and on the curve. This point A which you have, its x coordinate will be A. Its x coordinate will be A. And to find the y coordinate, what I will do, see here, this point has x coordinate A. To find the y coordinate, what I will do, I will substitute x equals to a in the equation of the curve. So if I put x equals to a here, put x equals to a in equation of curve. So when I do that, I will get y equals to f of a. I'm putting x as a, so y equals to f of a. So I got a comma f of a. as the coordinates of this point. A comma f of a are the coordinates of the point where you have the tangent to the curve. So you can write here T is line. This is line, okay? So line T is tangent to y equal to f of x at point a comma f of a. Okay. So see students, what I have. I have I have a curve y equals to f of x, and I have a tangent. I have a tangent to the curve at point A. I have tangent to the curve at point A. I know the coordinates of point A. Now next. Now what I will do is I'm going to draw a perpendicular to this line tangent at A. Remember students, you can have infinite perpendiculars to tangent. These all lines are perpendicular to tangent. Yes, they all are perpendicular to tangent. The angle between them and tangent is 90 degree. But remember students, we are not interested in these perpendiculars. We are interested in a line which is, try to understand this. We are interested in a line which is perpendicular to tangent, and that perpendicular is at A. It is at A. So here I have that. See, I'm interested in this. So what do I have? I have a line which is perpendicular to the tangent at point A. And what was that point A, my dear student? That point A was perpendicular to, that point A was the point of contact of tangent. Point A was the point of contact of tangent. So this red line is known as tangent to the curve y equals to f of x at point A, and this orange line is known as normal to the curve. It is known as normal to the curve y equals to f of x at point A. So here I will write line N. I will write here line N is normal to y equal to f of x, that is the curve. It is normal to the curve y equals to f of x at point A comma f of A. So here we have y equal to f of x, which is a given function. It means we are given the equation of the curve. Now to this curve, we have, on this curve, we have a point a f of a. On this curve, we have a point a f of a. On this curve, we have a point a f of a. So remember two things. When we have equation of the curve and we have one point on the curve, with these two data, that is equation of the curve and the point on the curve, we can get the equation of the tangent. We can get the equation of tangent. We can find equation of this line, and we can also find equation of normal. But now how it is done? Let us write the steps. So here I will begin with steps. So the first one is I write steps to find equation of tangent and normal. Equation of tangent and normal. TGT stands for tangent. Steps to find equation of tangent and normal. 2. Curve y equal to f of x at a point x1 comma y1. Let the point on the curve be x1 and y1. Okay, so let us start writing the steps. Step number 1. Step number 1. What you will do? Differentiate the equation of curve to obtain dy by dx equals to f dash x. Listen students, you are finding the equation of tangent to the curve. What is the equation of curve? Y equals to f of x. So what you will do? You will differentiate this curve. You differentiate it. You got dy by dx equals to f dash x. Now what is next thing that we will do? I will write here substitute x equals to x1 and y equals to y1 in let me write this as equation 1. X equals to x1 and y equals to y1 in equation 1 to obtain dy by dx at x1 y1 This is very important step. Students, what we will do? After we will have differentiated, we will get dy by dx. What we will do? In this dy by dx, wherever you see x, you will put x1. And wherever you see y, you will put y1. Why? Because you are finding the equation of the tangent at the point x1, y1. At the point x1, y1. It is like this point which I wrote as a f of a, that is taken as x1 comma y1. Okay. So what we will do? We will substitute x as x1, y equals to y1 in this equation to obtain dy by dx at x1, y1. And it is written as this. See here. dy by dx at x1, y1. What it will be? It will be f dash x at x1, y1. What are you going to do, student, here? Nothing. You will simply put in dy by dx, you will put where you have x, you will put x1, where you have y, you will put y1. This is very simple. When we'll solve the problem, you will understand. Okay. Now, see, this thing which you found, this thing, what thing? dy by dx at x1, y1, this thing. This is known as slope of the tangent at x1, y1. This, what you found, this number, this is known as slope of the tangent at, so I write here, equals to, this is equal to slope of tangent to y equal to f of x at x1, y1. So what I will do is, I will call this as m. I call this as m. So I got slope of the tangent at x1, y1. I call this as m. I write let m equals to slope of tangent to curve y equal to f of x at x1, y1. What does it mean? It means that this value which you got, this value which you got, or this value, it is equal to m. That is what it means, nothing else. So we have now got the slope of the tangent. See students, we got the slope of the tangent. I got the slope of this line. Which line? The tangent line. I got the slope of this tangent line. So when I have the slope of this tangent line, can I get the equation of this line? See, I have the slope of this line. Which line? The red line. I have the slope of this line. Can I get the equation of this line? Yes, we can get if we have one point on the line. If I have one point on the line, I can get the equation. So see here, the one point on the line in this diagram, it is x a f of a, but what I considered while writing the steps, I considered it to be x1, y1. I considered it to be x1, y1. So this point, remember this point is a common point. It is a common point to the curve as well as the tangent. This point is the common point to curve and the tangent. This point coordinates are x1, y1. So I have one point on the tangent and I have the slope of the tangent. What is slope of this tangent? Slope we found equals to m. So can I get the equation of this tangent? Yes. We will get the equation of the tangent in slope point form. What is it? Y minus y1. Y minus y1 equals to m into x minus x1. Okay, so here I write, therefore, I write here, therefore, the equation of slope, therefore the equation of tangent at x1, y1 can be given in slope point form, as follows. What is it? Y minus y1 equals to m into x minus x1. We got the equation of the tangent. What we got? We got equation of the tangent. After this, we'll go for equation of the normal. Please write this first. So after calculating, after finding the equation of tangent to the curve, after finding the equation of tangent to the curve at x1, y1, what is the next step? The next step is we will find the equation of normal to the curve at x1, y1. We will find equation of normal to the curve at x1, y1. See, here we found the equation of tangent. We found the equation of this line. We found the equation of this line. I am overdrawing this. See, we found the equation of this line. Now we want to find equation of normal. Where is normal? See, this is normal. We want to find equation of this. How will I do it? Very, very, very simple. See students, you understand that normal to the curve at point A Normal to the curve at point A is perpendicular to tangent at A. I know the slope of tangent. Slope of tangent we have calculated. How did we calculate the slope of tangent? Remember the steps? How did you calculate the slope of tangent? The first step is the curve to which the tangent is being drawn. You will differentiate the equation of that curve. You will differentiate the equation of curve, right? Then at what point is the tangent drawn? The tangent is drawn at x1, y1, so you will substitute x1, y1 and you will get the slope of the tangent at that point. Now, students, as I know that normal and the tangents are perpendicular to each other, see, I will write here. I write here the tangent to curve y equal to f of x at x1 y1 is perpendicular to normal perpendicular to normal to the curve normal to the curve y equal to f of x at x1 y1 at x1 y1. See students, you will notice that I am writing this particular group of words again and again. See, I wrote tangent to the curve y equals to f of x at x1 y1. Tangent. Some students, they have practice of, they will say only tangent. See, in this topic, that will not be sufficient. Why? When you say tangent, first of all, tangent to what? So, tangent to the curve. Next, if tangent to the curve, then where at x1, y1? Why? Because understand students, a curve, if you have a curve, there can be infinite tangents to this curve. Try to understand. You can have a tangent at this point. You can have 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 infinite tangents. Try to understand. You can have a tangent at this point. You can have a tangent at this point. You can have a tangent at this point. So at every point you can have a tangent. At every point you can have a tangent. So simply saying tangent is not enough. What you will say? You will say tangent to the curve y equals to f of x, and you will also mention at what point. So I just wrote that tangent to the curve y equals to f of x at x1 y1 is perpendicular to the normal to the curve y equals to f of x at x1 y1. Okay, that is clear from the diagram. That is clear from the diagram. You can check. They are perpendicular to each other. If that is the case, I know by geometry of straight lines. See, I know that therefore slope of tangent multiplied to slope of normal equals to -1. When two lines are perpendicular to each other, the product of their slope is -1. Now slope of tangent you have already calculated. Slope of tangent is m. So you have therefore slope of normal equals to -1 upon m. You got the slope of normal. Now see, you have slope of normal. It means you have slope of this line. You have slope of this line. Can we get the equation of this line? Oh yes. Why? Because now we have slope of line n and we have one point on n. Remember, this point is also lying on the normal. So we will write the equation in slope point form. So here I write, therefore Therefore, equation of normal, therefore equation of normal to y equal to f of x at x1, y1 can be given in slope point form. It can be given in slope point form. And what will it be? Y minus y1 equals to slope. What is slope? Slope this time is minus 1 upon m. Y minus y1 equals to slope of the normal into x minus x1. And this is equation of the normal at x1, y1. That's the difference. See here, students, the difference between this equation, which is equation of normal, and this equation, which is equation of tangent, the difference is only the slope. Here the slope is m, and here slope is minus 1 upon m, because they are perpendicular to each other. They are perpendicular to each other. I hope you all followed it. Please copy this. Give heading equation of normal. What the heading is? The heading you will write here as equation of normal. Equation of normal. Please write. So here we have a question. Find the equation of tangents and normals to the curve at the point on it. So the first question is this. We have the equation of curve and we have one point on the curve. This point is on this curve. What we have to do, we have to find the equation of tangent to this curve at this point and equation of normal to this curve at this point. Okay, so let's begin. I will write here the given curve is, I will write here the solution. I write the given curve is, I mean the equation of the curve is, the given curve is what? Y equal to x square plus 2 e raised to x plus 2. What is first step? We will write here differentiating with respect to x. I write differentiating with respect to x. So d by dx of y equals to d by dx of x square 2x plus d by dx of 2 e raised to x, again 2 e raised to x plus 0. We got dy by dx. What is dy by dx? dy by dx is 2x plus 2 e raised to x. What is the point where we have to get the equation of the tangent? The point here is 0, 4. It is 0, 4 where we have to get the tangent equation. I will write therefore. Next step. What is next step? I find this dy by dx at 0, 4. So dy by dx at 0, 4. So what I do in this, I substitute where I have x as 0 and y as 4. So 2 multiplied with 0 plus 2 e raised to 0. 2 into 0 is 0 and e raised to 0 is 1. So 1 into 2 is 2. So what I got, I will get therefore, I will get here therefore dy by dx at 0, 4. Therefore dy by dx at 0, 4 is 2. And see students, this 2 which you got, it is nothing but the slope of tangent to the curve at 0, 4. So I will write therefore slope of required tangent is equal to 2. I will write this as m. Okay, fine. So what will be slope of normal? Therefore slope of normal, as we all know that normal is perpendicular to tangent. So slope of normal is minus 1 by 2. Negative reciprocal of this. Why, students? Remember, because the tangent and the normal, they are perpendicular to each other. They are perpendicular to each other. This is tangent, this is normal. Slope of tangent into slope of normal will be negative 1. Negative 1. So if this is 2, the slope of normal, if the slope of tangent is 2, slope of normal will be negative 1 by 2. Negative 1 by 2. This is what you got. So now we will have, so see, we have slope of tangent and we also have slope of normal. We can get the equation of tangent and equation of normal. So I will write therefore, see, I will write therefore equation of tangent. Therefore, equation of tangent at 0, 4 is, see, y minus y1. What is y1? y1 is 4. y1 is 4. So y minus 4 equals to, y minus 4 equals to m. m is 2 into x minus 0. So you got y minus 4 equals to 2x. y minus 4 equals 2x. So you'll have 2x minus y. Shift everything on the right. So 2x minus y plus 4 equal to 0. What is this? Students, what is this? This is equation of tangent. This is equation of required tangent. Now what we will go for? We will go for the equation of normal. I will write equation of normal at 0, 4. The point is same. Remember, it is the same point. We have to get the normal equation. So y minus y1, y1 is 4, equals to slope. What is, yeah, equals to m. What is m here for this? Negative 1 by 2. Negative 1 by 2 x minus 0. So now cross multiply. So you here you have 2y minus 8 2y minus 8 equals to minus x. So x plus 2y minus 8 equals to 0. This is equation of normal. You got equation of tangent as well as normal. Please copy this. So now we solve another question of similar type. What is it? We have to find the equation of tangent and normal to this curve at this point. Remember, student, this point is on this curve only. This point is on this curve. What we have to do? We have to get the equation of tangents and normals to this curve at this point. Let's begin. So I will write here the given tangent, sorry, the given curve is. Okay, so here we begin with the solution. We write the given curve is. This is number 5. The given curve is, I mean the equation of the curve. What it is? X into sine 2y, x into sine 2y equals to y into cos 2x. Okay, and what's the point? The point is pi by 4 comma pi by 2. At pi by 4 comma pi by 2. Let's begin. So here I write this as 1. What are the steps? I will find out. I will find out dy by dx. So I write here differentiating with respect to x. So d by dx of x sine 2y, x sine 2y equals to d by dx of y cos 2x. So we have therefore x sine 2y. So we have x derivative of sine 2y is cos 2y into derivative of 2y, that is 2 dy by dx. The x derivative of sine 2y, which is cos 2y into derivative of 2y, 2 dy by dx, plus sine 2y into derivative of x with respect to x, which is 1. We are using product rule here. Okay. Now, next is here I have y into cos 2x. So y d by dx of cos 2x minus sine 2x into derivative of 2x 2 plus cos 2x and d by dx of y. Okay, here also we used product rule. Next. Now I notice that there are two terms with dy by dx. I will write these two terms together at one place. So here I have dy by dx common. So I get 2x cos 2y, 2x cos 2y, 2x cos 2y minus cos 2x minus cos 2x. This dy by dx I take it to the left equals to minus 2y sine 2x minus sine 2y. What did I do? I shifted this to right. So minus 2y sine 2x minus sine 2y. So what will be dy by dx? dy by dx will be negative. Let me take this negative sign common. So negative is out. 2y 2y sine 2x plus sine 2y divided by 2x cos 2y minus cos 2x. Okay, what is next step? Next step is we will substitute this point. We will substitute this point in dy by dx. That is our next step. So here I write therefore dy by dx at 5 by 4 comma 5 by 2. What does it mean? It means where you have x, you will write 5 by 4, and where you have y, you will write 5 by 2 in this. Okay, let's do it. So here we have negative sign outside and 2y. So 2y will become 2 into 5 by 2, 5 into sine 2x. Sine 2x, x is pi by 4. 2 pi by 4 is pi by 2 plus sine 2y, that is sine pi. Sine pi because 2y, y is pi by 2. So 2 pi by 2 is pi. Now in the denominator, 2x, that is 2x is pi by 2. 2x, so x is pi by 4. 2 pi by 4 is pi by 2. Cos of pi, 2y minus cos of pi by 2. Okay, wherever x is there, I write pi by 4. For y, I write pi by 2. Next step. So minus, see here, pi minus 1 is minus pi. I'm sorry, pi into 1. Pi into pi, sine pi by 2 is 1. So pi into 1 is pi. And outside, I have a negative sign. What do I have outside? I have a negative sign. So this negative is out, and here you have inside pi. Sine pi is 0, forget it. Then cos pi is minus 1. So you have minus pi by 2 minus cos pi by 2 is 0. Sine pi by 2 is 1, sine pi is 0, cos pi is minus 1, cos pi by 2 is 0. I substituted all these values. So now what I have, so see this minus and minus cancels. I will get 2 pi upon pi, that is 2. So what we got? The final slope that we got, slope of the tangent is 2. So I will write therefore slope of tangent at pi by 4 comma pi by 2 is equal to 2. This is m. Can I get the equation now? Yes, very easily. We will use slope point form because see we got the slope and we have one point. This point is on the curve, but remember students, this point is on the curve, but remember, this is the point where the tangent is drawn. So this point is also on the tangent. So we can write the equation of the tangent using slope point form. So here I will get, therefore the equation of tangent is given as y minus y1. What is y1? Pi by 2 equals to m 2 x minus pi by 4. x1 is pi by 4. So here you have 2y minus pi upon 2 equals to 2x minus pi by 2. So what I do is I multiply 4 by 2. So I get 2y minus pi equals to 4x minus pi. 2x, 2y minus pi equals to 4x minus pi. What is the next step? This pi cancels. I get 4x minus 2y equals to 0. That is 2x minus y equals to 0. What is this? This is equation of tangent. Then we'll go for the equation of normal. See, students, for equation of normal, first you will have to get the slope of the normal. What you will have to get? You will have to get the slope of the normal at the same point where you have the tangent. I will write slope of normal at pi by 4 comma pi by 2 will be negative 1 by 2. Very simple. Whatever slope of tangent you have, its negative reciprocal. That is, you write its reciprocal and also put the negative sign. Okay. So what is it? You will get minus 1 by 2. So I will write therefore equation of normal at the given point. Equation of normal at pi by 4 comma pi by 2 will be y minus y1 is same pi by 2 equals to slope, that is m. See, here you wrote slope as 2, but here you will write minus 1 by 2. So minus 1 by 2 x minus pi by 4. Okay, take LCM here, 2y minus pi upon 2 equals to minus 1 by 2 x minus pi by 4. Don't do anything here. Now see, this 2 and 2 cancels. This 2 and 2 cancels. Okay, so you have 2y minus pi equals to minus x plus pi by 4. Minus x plus pi by 4 you got. Okay, now shift everything on this side. So you have x plus 2y, This is pi minus pi by 4. That is minus 5 pi by 4 equals to 0. Minus 5 pi by 4 equals to 0. This is equation of normal. Okay, so students, I have solved a few problems for you, and few of these problems you can solve. Okay, we stop here. Enough for now.